Hello everyone, welcome to this session. Our chapter is compounds of metals, and today let's discuss about the metal carbonates and the metal hydrogen carbonates. So far in our previous video we covered about the metal these hydrogen hydroxides. So we've covered about the hydroxides. We saw their various uses. So today let's move on to this other part. We'll see these metal carbonates and the metal hydrogen carbonates. So let's dive into it. We'll start with the occurrence of the metal carbonates. How do the metal carbonates occur, or how do they appear on our Earth's surface? There are many types and forms of metal carbonates in the Earth's crust. So there are various kinds of types of these metal carbonates in the Earth's crust. The most common and the important carbonate is the calcium carbonate, which occurs naturally in the form of chalk, limestone, or marble. So this is the most common one of the carbonates, that is this calcium carbonate, which just naturally occurs in these kinds of forms, chalk, limestone, or marble. Now, carbonates of other metals are such as these of iron, copper, manganese, lead, and zinc. Also, they occur naturally. So these are just other kinds of these metal carbonates which they occur naturally. The iron carbonates, copper carbonates, manganese carbonates, lead, and zinc carbonates. Shells of snail, tortoise, fish, and eggs are just made up of great deal of all these carbonates. So you can find these carbonates naturally from these kinds of things. Now let's see the occurrence of the metal hydrogen carbonates. We've seen how these metal carbonates, how they occur on our Earth's crust or on our Earth's surface. So how do these metal hydrogen carbonates occur? There are just four solid hydrogen carbonates. These are as follows. There are potassium hydrogen carbonates, sodium hydrogen carbonates, lithium hydrogen carbonates, and the ammonium hydrogen carbonates. So these are just the four solid hydrogen carbonates which are there. The hydrogen carbonates of calcium and the magnesium, they also occur in solution form. The hydrogen carbonates are simply they are bases just like other ordinary carbonates. All metal hydrogen carbonates are just soluble in water. So these are just kinds of some characteristics of these metal hydrogen carbonates. The aluminum, zinc, iron, lead, and the copper hydrogen carbonates, simply they do not exist. So exception to all other metal hydrogen carbonates, the hydrogen carbonates of aluminum, zinc, iron, lead, and copper, they simply do not exist. Now let's see the preparation of the metal hydrogen carbonates, how you can prepare these metal hydrogen carbonates. The method that is used to prepare these carbonates depends on whether the carbonate is soluble in water or not. So you can simply prepare the metal carbonates simply by knowing their solubility, that is the ability to dissolve in water or not. Now the sodium, potassium, and the ammonium carbonates, they are the only soluble metal carbonates. So you have to note this, that these sodium, potassium, and the ammonium carbonates are simply the only soluble metal carbonates which are there. Others, they're just insoluble. Now the method to prepare the metal carbonates. The soluble carbonates which we've seen, they are prepared by simply passing carbon dioxide gas to the alkali. So you can simply prepare these soluble carbonates by simply passing the carbon dioxide gas to these alkalis. For example, the sodium carbonate is simply formed when the carbon dioxide gas is blown through the sodium hydrogen solution. As you can see, when you take the sodium hydroxide, when you pass first with oxygen gas, will result to sodium carbonate plus water. So that's the first way you can prepare this sodium carbonate. Now if more carbon dioxide is bubbled through the solution, a second reaction occurs and the sodium hydrogen carbonate is formed. So you can see how you can prepare the hydrogen carbonate, simply this sodium hydrogen carbonate, by passing through this carbon dioxide through the solution of this sodium carbonate. So if you pass sodium carbonate with the more of the carbon dioxide, then you resort to sodium hydrogen carbonate with presence of this kind of water as a liquid. Oh, so this is the easiest and the convenient way for preparing hydrogen carbonates. So you can simply prepare the hydrogen carbonates by this way. Uh, Insoluble carbonates can be prepared simply by precipitation reactions. It involves adding a soluble carbonate to a solution of salt of heavy metal. So you can simply prepare the insoluble carbonates, whether it can be the hydrogen carbonates or just carbonates, uh, by simply adding a soluble carbonate to a solution of salt of heavy metal. For example, when a solution of zinc carbonate is mixed with the sodium carbonate solution, a precipitate of zinc carbonate is formed, as you can see in the reaction. So that's an example of how you can prepare these insoluble carbonates. Likewise, the copper carbonate, it can also be precipitated by mixing the copper to chloride solution with potassium carbonate solution, as you can see in the reaction. So that's the other way. Now you can prepare like this the copper carbonate. Now let's see the classification of the metal carbonates. So we'll see how these metal carbonates they can be classified. From what we've discussed previously, you can get simply how the metal carbonates they can be classified. So the metal carbonates are classified based on their solubility in the water. Now, based from that concept, you can know that the classification on this basis we can have the two kinds of metal carbonates, which are soluble and insoluble carbonates. Now, potassium, sodium, and ammonium carbonates, they are soluble in water. All other carbonates are just insoluble in water. So you can classify the metal carbonates like that way. So I hope that's all clear, guys. Thank you for listening. We've discussed the metal carbonates and the hydrogen carbonates. We've seen their occurrences and how you can prepare them. Then we've seen the classification of these metal carbonates. I hope that's clear, and thank you.